So let's kick things off by discussing the coordinate plane. A coordinate plane is a tool used to measure the distance between 2 points and the steepness of a line. So this is our coordinate plane. It's a two-dimensional figure that helps us lay out points in space. So these are our 2 points that exist on this line here. So we'll be able to use a coordinate plane, our x and y axes, which we'll discuss more in a second. We're able to use this set of axes to figure out the distance between these 2 points, as well as the steepness. The steepness is how quickly this line rises over how quickly it's crossing horizontally. And we'll discuss slope thoroughly later on in this chapter. The horizontal line here is called the x-axis. The vertical line here is called the y-axis. And as we see, they intersect, forming perpendicular lines or 90-degree angles at each one of these 4 angles here. So this is 90 degrees, this is 90 degrees, this is 90 degrees between the 2 black lines, and this is 90 degrees as well, giving us a total of 360 degrees all around in our two-dimensional space. Now, a point is defined in a coordinate plane by its location along the x and y axes. And a point is usually given to us as a coordinate. The first number in that coordinate inside our parentheses is the value of the x, and the second value inside the parentheses is the y. And as we see here, they are always separated with a comma. So this point here has a location of 3, 3. This first 3 represents the x value, which is this number. The second number represents our y value, which is here. So this point is positive 3 along the x-axis and positive 3 along the y-axis. Hence the coordinate 3, 3. Now, how do we know that these are positive? To the right of this y-axis are the positive x values, and to the left of the y-axis are the negative x values. So here we have our positive values as we move away from the origin. And here we have our x values as we move to the left. With the y values above the x-axis, so above the horizontal line, are the positive y values, and below the x-axis are the negative y values. So knowing this helps us figure out what values each point has in this overall coordinate plane. So this point has a negative x value since it's to the left of this y-axis. It's negative 3. And you have to go down, which means we're going below the x-axis, which means its y value is also going to be negative. So we have positive x, positive y in this quadrant, negative x, positive y in this one, negative x values and negative y values in this one, and positive x values and negative y values in this one. Now, the x and y axes intersect at the origin, or where both axes have a value of 0. So here at the center, x is 0 and y is 0. And as we move to the right, they become positive for the x, or to the left, they become negative for the x. As we move up, we get our positive y values. As we move down, we get our negative y values. But where they meet, both have a value of 0. This is also known as the origin. Now let's discuss lines a little bit. A line is a collection of points between the first point and the second point. Now, which point you choose as your first or second point is up to you. This one can be considered your first point, and this one can be considered your second point, x2 and y2. Conventionally, since we read left to right, the point furthest to the left is considered our first point, or at least that's what I'll be using throughout this video. And as you move to the right, you get your second point. But as you're calculating different values, it actually does not matter. You can use the first point as x2 and y2, and this point as x1, y1. Just make sure this x value and this y value stay together, and this x value and y value stay together. That's the most important thing. Let's discuss the standard form of a line. If an equation can be written in this form, ax plus by is equal to c, where a and b cannot both be equal to 0, it is called the standard form of a line. So what does this mean? The standard form can be used to confirm whether or not a specific point, xy, exists on a line. So a line is a collection of points, and in standard form, we can figure out if any one of these particular points exists on the line given. You would be given a question like this one. Is the point 2, 3 on the line negative 3x plus y is equal to negative 4? So this is our standard form. We have our x and y on the same side of the equation and the constant on the right side of the equation. So how do we figure out if a specific point given to us exists on this line? There's really one step to figure this out. You plug the point into the equation. So we take the equation in standard form, negative 3x plus y is equal to negative 4. We plug in 2 for x and 3 for y. This is our x coordinate, this is our y coordinate. So when we plug in 2 for x and 3 for y, we get negative 3 times 2, which is equal to negative 6, plus 3. Negative 6 plus 3 is equal to negative 3. And when we plug in this particular coordinate, the left side of the equation does not equal the right side, which means this is not true. And if the equation is not true, then the point is not on this line. So the answer would be no, 2, 3 does not exist on the line negative 3x plus y is equal to negative 4. If you were given a value that did work, so if we did get negative 4 is equal to negative 4, then we know that the point does exist on this line. So that is how you figure out if a point is on a line. Let's have you do a few practice questions. Is the point 1, 1 on any of the following lines? Question number 1, 4x plus 2y is equal to 6. Question number 2, negative 5x minus 3y is equal to negative 4. And question number 3, negative 20x plus 4y is equal to negative 16. Pause the video, answer these questions, and then press play when you are ready to begin. Question 1, step 1, plug the point into the equation. So we have the same point for each one of these questions. It's positive 1, positive 1. So we plug in 1 for x and 1 for y. And we get 4 times 1, which is 4. 2 times 1 is 2. 4 plus 2 is equal to 6. And since the left side equals the right side, we know that this point, 1, 1, does exist on this line. 4x plus 2y is equal to 6. Question number 2. Step 1, plug the point into the equation. We plug in 1 for x and 1 for y. Negative 5 times 1 is equal to negative 5. Negative 3 times 1 is negative 3. Negative 5 minus 3 is equal to negative 8. Since the left side does not equal the right side, we know that this point, 1, 1, does not exist on this line. negative 5x minus 3y is equal to negative 4. Then the last question, step 1, plug the point into the equation. Negative 20x plus 4y is equal to negative 16. Plug in 1 for x and 1 for y. You get negative 20 times 1 is negative 20. 4 times 1 is 4. Negative 20 plus 4 is negative 16. Since the left side equals the right side, that confirms that 1, 1 does exist on this line. Negative 20x plus 4y is equal to negative 16.